Good afternoon, Laracon. How are you all doing? Awesome. Thank you for that really warm welcome. I really appreciate it. It's made me feel a little bit more settled here on the stage. Today we're going to learn how to fly with Laravel Reverb. And we're going to split down this talk into two parts. The first part is going to be quite theory heavy, so I hope you're all suitably caffeinated. But we're going to redress the balance in the second half, and we're going to jump into a really fun demonstration. But before we get too far into it, there's a little bit of housekeeping that we need to do. In case you couldn't tell from my walk-on music or the accent that I'm speaking to you with now, I am indeed from the UK. And that means there are a couple of subtle differences between the flavor of English that I speak and the flavor of English that most of you in the crowd speak. So we're just going to align on a few terms before we get started so that you don't get confused later on in the talk. Okay, so apologies in advance for this one, but being from the UK, we say sorry all the time. It's just what we do. If we're walking around the venue later and you bump into me, I'm going to apologize to you. That's totally normal. Don't worry about it. And first off, I'm sorry for that. Sorry, we jumped on two. Okay, so when it... Huh? Oh, sorry, yeah, again. Okay, so when I say the word football, you're probably all more familiar with the term soccer. And when I say route, what I really mean is route. And when I say beta, I mean beta. And finally, when I say tickety-boo, that means all things are great. Okay, so now we have that sorted. Let's talk a little bit about me. I am Joe Dixon, and I had the absolute honor and privilege of not working with just these guys, but the entire incredibly talented, awesome Laravel team in my role as engineering team lead on the cloud project. Now, fun fact about this photo, Christoph took this yesterday while Taylor was just announcing cloud to the world. And this is the whole team making sure that everything ran smoothly. I live with my wife and two kids, and I feel a little bit guilty right now because I left for Dallas on Sunday afternoon, and I have yet to call them. I've been so busy since I've been here. But thankfully, assuming the stream is working, they are watching. So I just want to call out to them and let them know I am okay, and I will check in and call you right after I get off stage. We live in a small city in the UK called Norwich, where we're lucky enough to have 2 cathedrals, 1 castle, and the best football team in the world. Now, quick show of hands, does anybody recognize this guy on the screen? All right, we got 3 or 4 football fans in the room. That's good. Yeah, this is, in fact, Norwich's best player when he's not injured, and US national team attacking player Josh Sargent. So yeah, when I'm not at my keyboard, I'm away from my keyboard, I'm chilling, I'm hanging with my family, or I'm watching football, or I'm watching Formula 1. Okay. That was a ChatGPT creation. And if I'm not doing those things, I'm probably drinking coffee. I'm a bit of a coffee nerd. So if any of you want to switch gears from talking tech during the conference, find me walking around. I'm happy to talk with you at length about any of these topics. Okay, enough about me. Let's jump into the meat of this talk. We're going to be talking about Laravel Reverb. So to start, what is Laravel Reverb? Well, in short, Reverb is a first-party package from Laravel. It provides real-time WebSocket communication to our Laravel applications. It's blazing fast, incredibly efficient, and built out of the box to scale. We announced Reverb back at Laracon EU, in February of this year, before releasing the first beta version on March the 12th, in line with the release of Laravel 11. And after a successful beta period, we tagged V1 on July the 2nd. And the nice thing about us being able to line up the release of Reverb with the release of Laravel 11 was that we could lean into some of the slimming of the skeleton that made it into that release. And in particular, we can hook into the install broadcasting command. So if you want to enable broadcasting in your Laravel application, you now have to run this PHP artisan install broadcasting command. And because that command now exists, we're able to make the install process of Reverb incredibly easy. In fact, when you run that command, you're immediately prompted if you want to install Reverb. And if you do, it's going to go ahead and install Reverb into your composer dependencies and update them there and then during the command. And in a similar fashion, it will do the same with Laravel Echo, the front-end companion for Laravel's broadcasting capabilities. It will add that if you want to install it, it will add it to your node dependencies, update your node dependencies, and recompile your front-end assets. And finally, we set a really sensible set of default configuration options. So all that's left to do after that command has run is to start your Reverb server with PHP Artisan Reverb start. And at this point, you have a real-time WebSocket connection between the back end and the front end of your application, and you're able to send events between the two in real time via WebSockets. My slides are not moving. Thank you for the applause then. So to understand how Reverb can benefit our applications, we probably need to take a little bit of a deeper look into what WebSockets actually are. And to do that, let's look at a UI component that we've probably all built a million times over, something like a status indicator. Now, a status indicator is something that we want on the front end of our application, which reflects the state of our back end application. So if we're processing jobs or webhooks or running commands in the back end of our application which are updating state, we want those changes reflected on the front end of our application in real time. And there's a couple of different ways that we can approach that. Probably the approach that we're most used to taking is something called short polling, where the client will kick off a request to the server to ask for an update of the status. And the server will send a response back, and the client will update the UI accordingly. And then we wait for however long we feel is right before kicking off that process again and again. And depending on how long that wait time is in the middle, we can start to build up something which feels real time. Of course, it's not real time. We have these waits in the middle, and we're making multiple expensive HTTP requests every time we do this. WebSockets work a little bit differently. So we still have our client and our server. Our client makes a request to the server, and then we go through a slightly different handshake negotiation to your standard HTTP handshake negotiation. But assuming that negotiation completes successfully, we end up with this open pipe, this WebSocket between the client and server, which the client and the server are free to send data between each other as and when they need it. And this connection will remain open for as long as we need it to be. And so we're not making multiple HTTP requests. We're making one HTTP request, which gets upgraded to a WebSocket connection, and then that's a long-lived connection which we can use as and when we need. But how does Reverb work? Because typically when we're building PHP applications, we are used to taking a request, processing it, and sending a response back to the client, closing it down, and then kicking off the next one. So for Reverb, we had to think a little bit differently. And after trialing multiple approaches, we landed on using a low-level library called React PHP. And React PHP takes an event-driven paradigm. And it's incredibly efficient. It allows us to act in a non-blocking asynchronous fashion. Essentially what it allows us to do is take a connection, allow it to sit in memory, and only act on that connection as and when new data is available. And I want to talk to you a little bit more about how that works now. Okay, so full disclosure, this is where the next 3 slides are quite theory heavy. So if I can keep your attention, I'd be really thankful, and then we'll redress the balance and we'll have a whole lot of fun in the second part. So with React PHP, it all starts with an event loop. And this is the lowest level React PHP component which we have available to us, and it's what powers everything that all of the components that React PHP has on top of that. And what might be interested to know is it's nothing really any more than a while true loop. It's an infinite loop. But 3 things happen on each iteration or tick of our loop. The first thing we do is process future ticks. Now this might sound a little bit counterintuitive, but what future ticks are things which have happened on a previous iteration of the loop, which we've pushed to a future tick of the loop. So in our current iteration, we're processing something which we deferred from a previous loop tick. And that's really useful for doing things like chunking up huge jobs into smaller ones. Because if we do huge compute-intensive jobs on each iteration of the loop, we start to block other events from being able to be processed. This is all single-threaded, so it can be incredibly efficient, but we have to figure out and we have to work with it to understand what the most efficient way of doing things is. Okay, so the next thing that we process is timers. Now, these are things which we may want to schedule on a one-off basis in the future, or things that we want to schedule on a periodic basis, so every 1 second, every 5 seconds, every minute, or every 10 minutes. And Reverb actually leverages timers quite heavily for doing things like pruning stale connections and actually ingesting events into our first-party integration with Laravel POS, which is how we monitor the performance of our Reverb server. And finally, and perhaps the most powerful part of the event loop, is if we process input, output, and streams. I'm going to talk about this a little bit more in the next couple of slides, but this is where things get really exciting, and we can do some really cool things. So once input, output, and streams have been processed, the loop tick completes, and it starts again. And so every event that's been queued up will get processed every event that gets queued up from the previous iteration of the loop will get processed on the subsequent iteration of the loop. It turns out this is incredibly efficient. But how do we use this in Reverb? Well, we still have our event loop. We're going to deal with some input, output, and streams because at the base of it, we're dealing with HTTP connections. And to do that, we're going to leverage another component of React PHP called the socket component, which allows us to start a TCP server on our event loop. And what that does is the TCP server is started on a host name and port number, and it just listens for new connections. So in the case of Reverb, let's walk that through. We have a client who wishes to connect to our WebSocket server. You can see, okay. You can see on the bottom right-hand side of the screen that we're making an HTTP connection here. It's a standard HTTP GET request, but there's a couple of additional headers which we may not be so familiar with seeing. And these are the things which make WebSockets possible. We're asking the server to upgrade the connection to a WebSocket connection, and we are sending through some other headers which are used in the handshake negotiation process. So Reverb is sitting listening for that connection. And when it receives it, on the next iteration of the loop, we process it. And then Reverb understands that this is a WebSocket connection. And we go through the handshake negotiation process, and assuming that all works out correctly, we end up with a user stored in memory. But of course, we need to notify that user that connection has been established. So we queue up an event on our loop. We now have an open stream between our client and our server, and we can push data between the two. But remember, this is event-driven. So the next time our loop ticks, that event which has been queued up will be processed, and we write that event back to our subscribed client, or our connected client. And this can happen multiple times, in this case 3, but Reverb is efficient enough that it can handle tens of thousands of concurrent connections on a single PHP process. So now our client wishes to subscribe to our status channel. This is the channel which we will broadcast to from the back end of our Laravel application to notify the UI that changes have been made. So they send that request across our WebSocket. That event will get queued up. The next time the loop ticks, Reverb picks up that message, understands that it's from user 1, and makes a reference that user 1 wishes to connect to the status channel. And the status channel is nothing more than a PHP array which stores references to subscribed clients. And of course, we want to do something similar as when our connection was successful. We want to let the user know that their subscription was successful. So we queue up that event, and the next time the loop ticks, we write that back to our connected client. Okay, so we have 3 users, all connected to our WebSocket server. One of those users is subscribed to the status channel. And now our Laravel application has detected some state change in the back end of our application and wants to notify those connected users, or the one connected user, in this case, that we have subscribed to our status channel. And that works a little bit differently. Here we're making a standard HTTP post request to the /event route. And this route isn't registered in our Laravel application. It's all handled by Reverb and the routes that it registers internally. And here you can see we're sending the payload which we want to broadcast to those connected or those subscribed clients. So again, that event or that connection gets queued up. The next time our loop ticks, we process it. Reverb understands that this is a request to broadcast that message. It's going to go ahead and look up the users subscribed to the status channel, and it's going to forward that event across to them. And so in this case, the next time our loop ticks, we're going to do two things. We're going to send our event onto our connected client, and we're going to send a 200 OK back to our Laravel application to let Laravel know that that event was broadcast successfully. So the next time the loop ticks, both of those events are processed, and both of our connected, our WebSocket connection and our web server connection are notified. And if you notice, the request that we had in memory has now disappeared. Because this is a standard HTTP request, once we've sent that 200 OK, we don't need to deal with it anymore. That's all completed. But our WebSocket connection to user 1 remains established, and that user remains subscribed to the status channel. So obviously, there's a lot more going on under the hood in Reverb, but in broad strokes, this is how it works, and this is how we're able to build something that's so incredibly efficient in PHP. Now, your mileage will vary depending on exactly what you're doing, but I've already mentioned that Reverb can handle a single Reverb server, single PHP process can handle tens of thousands of concurrent requests. In fact, we already have Laravel Forge and Envoy running on a single server. It's not a big server. We have both of them running on a single server because Reverb is multi-tenanted out of the box. And that server isn't even breaking a sweat, and we're processing millions of requests every day. But if you do end up in the situation where you are processing hundreds of millions of requests a day, or tens of millions of requests a day, then Reverb is built out of the box to scale horizontally. And this was quite an interesting problem to solve. So I want to just talk a little bit more about how we did that. So here you can see that we have our infrastructure set up. We have our load balancer, and sat behind our load balancer, we have 3 servers, each running Reverb. So we have a separate event loop for each one of those things. None of those servers are connected. They don't know about each other. But at the bottom, you can see that we also have a Redis instance. And this is where things get a little bit more interesting. So each of those Reverb servers are subscribed to a pub sub channel on that Redis instance. And that is all handled by the event loop as well. So if there's any events which are broadcast or published to that Redis pub sub channel, then those events will get processed on the next iteration, the next tick of the loop, as we just saw with Reverb itself. And that's going to be important. So we're going to look at what happens now when users start to connect. So our first user hits the load balancer. The load balancer sends that request to server 1, and that's now managing that connection and its subscription to the status channel. Now the second user connects. That hits the load balancer. The load balancer forwards the request to server 2. And the third user connects, hits the load balancer, server 3. So we now have 3 users, all handled, managed by different servers, but all connected to the same channel. Now hopefully it's already obvious what the problem is that we have to solve, but let's throw our Laravel application in the mix. So our Laravel application makes that post request to the /events route, and it hits the load balancer, and the load balancer sends that request to server 1. So ordinarily what would happen here is that our Reverb server would find all of the connections subscribed to the status channel and broadcast it to those connections. But because that post request has only been received by one server, only the user or the connection managed by that server would receive that event. So users 2 and 3 wouldn't receive it. So what happens instead is server 1, who's received the event, which has received the event, publishes that event to our Redis pub sub channel. And because we have those 3 servers listening on the same channel, the next time our loop ticks, each of those servers will receive the event, and each of those servers can then forward or broadcast the request onto the connections that they manage. So with this implementation of Reverb, you can really scale things as far as you need to go. And all things are tickety-boo. All right, let's have the fun part. Thank you. You're just going to have to give me a moment to set up. Okay, I'm not going to connect to Ben. Those lightning bolts are scary. Okay, we're connected. Okay, so what we have is this. I'm going to bump the size up a bit. This incredibly beautiful Nintendo Switch UI, which I have lovingly crafted with nothing but Alpine.js and Tailwind CSS. Yeah, I know, right? Who knew not all Tailwind sites look the same? Okay. So what we're going to do is build on this UI and make it interactive using WebSockets. So I'm also going to jump into my editor, and I wish this was a bit bigger out the gate. Can everybody see that okay? And we're going to run, not that, this reverb fly command. Now what you've probably noticed is that this isn't the reverb start command, and that's because we're going to be doing some things with the event loop which powers reverb. And so we need access to that. We're going to hand roll our own command. But let's jump back into our browser. Let's quickly open the network tab. And let's make sure we have a connection to our WebSocket server, which you can see that we do. So it's subscribed successfully, and we are subscribed to a channel, a private channel called Fly. Whew, right, let's see what this UI can do. All right. I bet you didn't see that coming. Okay, so we can fully control this drone from the UI. I can fly up. I'm going to fly it too high because if I take down one of those cubes, Taylor's going to kill me. And I can fly it down. I can fly left. I can fly right. I can fly forward, but not too far because I had to get special permission, and they told me I'm not allowed to fly this over the audience. I can fly back. I can even flip. All right. Cool. Okay, so that's pretty cool, right? We're using WebSockets to communicate with this drone using this UI. But what else can we do? What happens if I press this button? All right, now we're getting telemetry from the drone. So I can now fly left and right, and you can see the speed that I'm flying at. I can fly up and down, and you can see at the bottom left the altitude the drone is flying at. And the bottom right, you can see the temperature of the drone, and the top left, you can see the battery status. So that's pretty cool. And I've been told I can't fly this thing for too long, so at the risk of getting kicked out before I get to finish the talk, oh no, we don't want to land. I didn't press any buttons for long enough. Let's take off again. Here we go. I'm going to press this button and see what happens. In fact, I'm going to fly up a little bit higher first. Oh no. Ah. All right, let's see what happens when we flip. Okay, one more thing to show. I just want to show the performance of the event loop. So I'm going to have to refresh the page, I think. You can see all of the events that we have flying through via WebSocket. So all of the streaming events. I just had to press that before it landed again. All of the streaming events are just flying through here, and all of the video streaming events, all of the events that we are receiving from the drone, and I don't know if we'll be able to see it. Can't quite see it because these things are coming in too fast. But you'll be able to see the interaction that I'm sending to the drone as well. I'm going to come on to that a little bit more in a second. But as a little bit of fun, who thinks I can land this thing back in the box? All right, this is hard. Give me some help. Am I right? Left? Stage right. I don't know what that means. Whew. I can't tell you how scared I was about doing that. Okay, so let's have a look at what's actually happening here. So the first thing we're doing in the handle command, the handle method of our command, is we are instantiating a new event loop. All we have to do is loop : get, and we get a new event loop. And the first thing we're going to do is create our WebSocket server. And this is pretty much exactly what happens in the reverb start command. We're just using the server factory, and in this case, passing through our event loop and our configuration options, and creating our new WebSocket server, which will run on our event loop. So that's all reverb. That's nothing to do with the custom work I'm doing in addition. Then you can see we have these three methods: fly, status, and display. They all receive the same event loop. Fly is the method which controls the drone. Status is the method which allows us to read the telemetry from the drone. And display is the method which allows us to consume the video feed. So we're going to jump through these one by one. OK, so the fly method. Not too much happening here, but we've got a new class which we're not familiar with, this datagram factory. And this is another component which ships with React PHP. And it allows us to communicate over UDP, Universal Datagram Protocol. And that, as it happens, is what we need to communicate with our drone. So when we instantiate, or when we call this fly method and pass through our event loop, we're creating a client, because we want to be able to send messages to the server running, the UDP server running on the drone. When that connection is made, we receive our instance of our socket. That's the thing that we can use to interact with the drone over UDP. And I'm binding a singleton to the container, this fly service. And the fly service receives our socket. So let's jump through and have a look at what happens in here. So in the constructor, we're immediately sending the command statement to our drone. And this is the thing that tells it we want to be able to control it. It's just what we have to do to put it in the right mode. So that's going to happen as soon as this class is instantiated. And the only other thing that's interesting here is we have this send method, which pretty much does the same thing. We send a command to the drone. But where are those commands coming from? We need a string. It's just a short string that we pass to the drone to tell it what to do. How are we getting that from clicking the button in the UI into this service to communicate with the drone? And this isn't something I would necessarily recommend that you do, but I'm actually cheating the system a little bit. So Reverb ships with this feature called Client Whispers, and Client Whispers are designed for clients to be able to communicate with each other without having to interact with your Laravel application at all. So what happens is when you send a client whisper, that whisper is sent to Reverb, and Reverb then immediately just broadcasts that to all the other connected clients on that server. But Reverb also fires off a message received event on every message which it receives. So every time it receives this client whisper, it fires an event. And because it's an event, we can create our own listener. So in this handle command listener, we're listening for our message received event. And this is where things can get a little dangerous, because I mentioned before that if you do large amounts of compute work, large amounts of processing on each tick of the loop, then you're going to slow other things down from being processed. So you have to use this carefully. I would not recommend interacting with your database or making HTTP requests or anything like that. And worse than that, you can actually end up in a deadlock. So if you perform some action which relies on the next iteration of the loop, then those two things can never complete. And so our loop gets blocked completely. That's definitely not something that we want. But we're being really thoughtful here, and we're not doing too much work. We're basically interrogating the message on the event, and we are checking to see whether the string starts with client hyphen, which is what all client whispers start with. If it's not, we're bailing immediately. Otherwise, we are taking everything after the client hyphen, and that becomes our command. And then all we do is resolve our fly service from the container, and we pipe that command straight through using our send method to the drone. All right, so that's how fly works. Let's jump back into our command, and we're going to look at status. OK, our old friend, the datagram factory, is back. But this time, again, using the same event loop, we're creating a server, because we want the drone to be able to send stuff to us. So the drone communicates, or knows to pass data over UDP to this IP address and port that we have configured here. When that connection is made, we are listening for new messages on that server, and then we're just delegating everything to Reverb. Reverb ships with this event dispatcher, and we dispatch the event directly with an event name called state changed on our private fly channel, which I showed you we were connected to at the very beginning. And this pass state method is just what I use because the drone gives you a really gnarly string to give you all of the telemetry data. So I'm just passing that out, turning it into a PHP array, and making that useful when we broadcast it to the front end. So when the front end receives that event, it can cherry pick the data that it wants to render on the front end of our UI. OK, now for the big one. This was a fun one. I almost didn't get this working, but I'm glad I did. OK, so the display method, again, receives our event loop. And we're using another component of React PHP here. We're using the child process component. And what we're doing is firing off a separate command, but using, again, our event loop. And this command uses, or we're just firing off an ffmpeg command, which, again, listens on UDP, using the IP address and the port number of the server. And what we're doing and cheating a little bit here, what you saw on the screen wasn't a true video feed. What I'm doing is taking each frame of the video, converting that to a JPEG image, and piping that straight out to standard out. So again, a little bit further back up, we kick off our process here with the start method, and we pass through our event loop. And then we're able to start listening for events on standard out. So every time we receive a new data event on standard out, that's going to be our new image from ffmpeg. And again, we're just firing this off to Reverb. So Reverb's listening, we're listening for that event, and we're then using Reverb's event dispatcher to fire off an event called video stream on the same private fly channel, which we've talked about before. And all we're doing is base64 encoding that image chunk and firing that straight off to the front end. When the front end then receives that event, we are just taking that data, decoding it, and squirting it straight into a canvas tag. That screen in the middle of the UI is nothing more than a canvas tag, and we're just updating the image on a regular enough basis that it feels like a video stream. It's pretty cool stuff, and it shows the power of the event loop. We've got loads of things happening here. We've got WebSockets, HTTP connections being handled by our event loop and Reverb. And then we're communicating over multiple different types of UDP connection using the same event loop. And we're receiving tons of data from this drone and pushing more data to that drone, all on one PHP process, which I think is pretty cool. Okay. Thank you, I appreciate that. It was a lot of fun. Oh, sorry, Aaron. Too soon. That was a lot of fun to build. It was fun to build something that was a little bit different to your standard kind of chat app, but I think hopefully it's given you some inspiration of the kinds of things that you can do with Reverb and the event loop that powers it. So I'd love to hear the kinds of things that you're building with Reverb. If it's standard stuff, great. I'd love to kind of hear about how it's working, the performance you're getting from it, any problems you have that you think we could maybe address. And if you're doing quirky things with it, even better. I'd love to hear about that stuff too. I've been Joe Dixon. You can find me at _Joe Dixon. I'm only on Twitter. That's the only place I hang out, and I will go there until the sync ships. Thank you very much.
Hey, everyone. My bad.
Huh?
Sorry about that.
Did I get one of those cool?
Yeah, but you see, you came in up here, and I wasn't ready for it, so that was the whole thing.
I haven't learned that.
All right, a couple of questions. Primarily, we're going to start with this. When did this enter your mind for the talk? Were you doing a Reverb talk and then you're like, hey, here's a crazy idea? Or was this always the vision?
The original talk that I pitched was the same talk I gave at Laracon EU. And then we released the video from Laracon EU, and I thought maybe I should do something different. So then it took a while. I was iterating through a few different ideas. It's always going to be a Reverb-focused talk, but I wanted to do something a little bit out there. So I started to research whether any drones could be controlled via WebSockets, because I thought this would be quite cool. And it turns out we managed it.
And it was quite cool. It was very tickety-boo, if you ask me. Okay, next question. I'll give you two options. One is, where within Laravel and your first-party Laravel products is Reverb being used? That's option one. And option two is, what types of problems, like what is the shape, the characteristic of the problem that people should see when they're reaching for Reverb? So if you see this type of problem, Reverb is a good fit. Your choice.
Can I take both?
Yeah.
All right. So internally, Reverb, as I mentioned, is used on Forge and Envoy, not yet Vapor. And yesterday, it was all that real-time stuff on cloud was Reverb as well. The second question, I mean, it depends a little bit. I think if you have, like, cloud is the perfect example because there's loads of stuff happening behind the scenes. We're processing webhooks from GitHub. We're dealing with events that are happening during deployments, and we want all of that UI to feel real time. And to do that with short polling, with that amount of different things happening, would feel pretty wasteful. And so I think that kind of thing makes a lot of sense, but you've probably got to weigh it up and see what makes sense. And I'm going to give you the classic, it depends. It depends.
A good answer. The last question came from the audience. Can you tell us how to pronounce aluminum? Aluminum?
Oh, good one. That should have been on the slide. It's aluminium.
Aluminium. Everybody, Joe Dixon.
Thank you.